Okay, grade 12, bear with me. This question is going to be long and a bit involved, and so hopefully we can run through it correctly the first time. But it's a really good question to apply all your different areas of physics knowledge. So it is a preliminary past paper question from the Western Cape Metro Central. There's two different Western Cape papers. I don't know why, but that's how it works. And this one is really interesting for projectile motion, but it's projectile motion but also uses impulses, joining the two things together. So it says to you, a steel ball of mass 160 grams is thrown vertically upwards with a velocity of 3 meters per second from a certain height above the ground. On the way down, a very thin horizontal glass pane is pushed in its path. The ball crashes through it and then continues downwards, eventually bouncing on the ground. The velocity time graph below, not drawn to scale, shows the motion of the steel ball from the point of projection. Assume that none of the broken glass sticks to the ball. Ignore the effects of air friction and the thickness of the glass. Okay, so now ignore the effects of air friction is normal, and the thickness of the glass is because if it went through too thick a glass, it would change its travel distance or something silly like that. So these are just things that can, if you know more physics, can affect everything. So they're asking you to ignore it, and they're asking you to assume that none of the broken pieces of glass stick to the ball, because that would change the ball's mass and also mess up the calculations. So these last two sentences are just nonsense. Now, this is physics. What's the first rule of physics? It is draw a diagram. So this thing here, okay, if this is the ground here, can you see here's the ground? Okay, what's happening is it says the steel ball is thrown upwards from a height above the ground. So its starting point is going to be above the ground. It's going to go up, okay, and then it says on the way down. So we don't know where, but somewhere on the way down is a piece of glass. And the ball hits the piece of glass and then breaks through the glass, hits the ground, okay, and then bounces. And it doesn't tell you exactly what happened after it bounces, it just says it bounces. We can figure it out from the graph though. So it says the first part of the question is identify the two sections from the graph where the acceleration is not equal to 9.8 meters per second. Give a reason for your answer. Okay, first of all, you need to know that from the moment the ball leaves your hand, it is a projectile. The only force acting on it is the force due to gravitational pull, okay? So it has got a constant acceleration. But if you hit a glass pane, okay, and you collide with it, your speed is going to change because there's a force acting on it. And if we have a net force causes a change in acceleration. So when it hits the glass pane, its acceleration will change, and when it hits the ground and it bounces, its acceleration will also change because that's what happens when a net force is applied. So you know that when we look, this is a velocity time graph. I don't know if you can see that it's so small, but you should have your original copy with you. This is a velocity time graph, and usually with projectiles, velocity time graphs are like this, a bunch of parallel lines, and then there's like dots, or sometimes it's just left blank between them. So why are all of these lines parallel? Because if you put velocity divided by time, you end up with acceleration. So the gradient of the graph is always acceleration. So all of the parallel sections of this graph, like over here and over here and over here, can you see these are parallel? These are when the ball is acting as a projectile, and the only force acting on it is the acceleration due to gravity. So those are where the ball is a projectile, which means where the acceleration is different, which is over here and over here, this must be where the ball is either making contact with the ground or with the pane of glass. And now according to our diagram, the pane of glass came before the ground. So this one here is going to be the glass, okay, and this one here is going to be the ground. Now there's one more thing about this ball that you should look at while we look at this graph here. If you look over here, the ball is, the V is 0. This means somebody's probably caught this ball at maximum height on the second bounce, okay? Because if it was going to hit the ground, remember, when you're going up, this graph is clearly up is positive because the acceleration, the gradient is negative, and that means we've said up is positive. So when the velocity is 0, is at maximum height, and so then this ball here was caught at maximum height by somebody who probably hurt their fingers if it was a steel ball. Okay, so it says identify two sections from the graph where the acceleration is not equal to 9.8 meters per second. So this is going to be CD and EF, and the reason is the gradient of the graph, which is acceleration changes. So it is no longer a projectile. Okay. According to the information provided on the graph, how many times did the ball bounce on the ground? So they're checking your understanding here, because usually, remember I said to you, get all those bouncing ball graphs. And usually when you've got 3 lines, then you've got 2 bounces, because the bounces are in the middle. But here we've got the glass, and then the other change of acceleration is on the ground. So this ball has only bounced once. It only hit the ground once, because look here, it went up, hit the pane of glass, hit the ground, came up to maximum height and was caught. Now it says 4.3, use only the information provided on the graph and calculate the maximum height reached by the steel ball above the point of projection. So this is easy enough if you haven't scribbled all over the graph and can still read the writing. Okay, if we want to find the maximum height, we are looking for delta y. Okay, so we're going to use these equations of motion, and we know from reading off the graph, this is our VI, it's also in the question, and at maximum height, VF is 0, and it's a projectile, it's accelerating at the acceleration due to gravity. So we can use VF squared equals VI squared plus 2a delta y, this equation of motion over here. Okay, so my final velocity is 0 squared, which is 0, so I'm not writing it in. 3 squared from the graph up is positive, so this is going to be plus 2 times negative 9.8 delta y. Okay, and you end up with delta y equals 9 over 19,6, which is 0,459 meters, which we should round off to 0,46 meters. Okay, now it says to you, so what was this? 4.3.1. Now let's look at 4.3.2. It says calculate the distance between the pane of glass and the initial position from which the ball was thrown. Ignore the thickness of the glass pane. Okay, so now you found the distance to maximum height. So if you really wanted to, you could find the distance from here to here and figure it out. But I don't see why you have to do that, because we know the initial velocity. We know the final velocity because we know it's at this point C here that it hit the pane of glass. So if we say our initial velocity is 3 and our final velocity is its velocity when it hit the pane of glass, which is negative 1.9, we know the A is negative 9.8. Simply because this is a displacement and a velocity question, we can find the distance between the pane of glass and the initial position using exactly the same equation again, okay, but with different values. VF squared equals VI squared plus 2a delta y. My final velocity is negative 1.9 squared, and it's going to be equal to 3 squared plus 2 times negative 9.8 delta y. Okay, so you end up with 3,61, that's 1.9 squared, minus 9 equals minus 19.6 delta y. And from there, with your calculator, you can get delta y to be 0,275 meters. So like I said, you could calculate, okay, it's this far to maximum height, it's this far to the pane of glass, and then find the difference between the height to maximum height and the distance it travels from maximum height to when it hits the glass. But because these are vectors and this is a negative value, you can just straight put it into the equation and come up with the correct answer. Now it says 4.4, calculate the impulse of the glass, impulse of the ball while it's in contact with the glass. Impulse belongs with the momentum things, okay? So impulse is, what is the definition of impulse? It is the change in momentum. It's delta P, okay? So delta P equals mvi minus mvf, sorry, minus mvi. So the change in momentum, the ball is not changing mass, but it's in grams, so we have to convert it to kilograms. So it's 0,16 kilograms. What was my final velocity? It's minus 1,9, because it says to you the impulse, no it's not, it's minus 0,6. Yes, look over here. When the pane is hitting the glass, agree it's at CD, okay? Remember we decided that it's hitting the glass at CD. So its impulse when it's in contact with the glass is the change in momentum between C and D. So the final is minus 0,6, and my initial was minus 1,9. So a minus and a minus is going to become a plus, and then by the power invested in us with calculators, yes, we get 0,208 if you do the maths. And remember your unit, this is going to be a Newton second, or it's the kg meter, that other unit that I can't remember, but the Newton second is easier. Okay, so that's the impulse of the ball. Okay, now it says after crashing through the glass, the time for the ball to reach the ground is t. So what are they talking about here? Where is the time for the ball to reach the ground? It is this section of the graph here, okay, which corresponds to this part of my little drawing over there, okay? So it says after crashing through the graph, the time for the ball to reach the ground is t. Okay, so let's have a look here. This is now t. Analysis shows that the ball made contact with the glass for 1/1,2 t. So this section here, CD equals 1/1,2 t, and then DE equals t. Okay, so this is why this question gets interesting. So it says to you, show that the contact time of the steel ball with the glass pane is 0,289 seconds. So this CD, okay, is 0,289. Now, one of the reasons they've asked you to prove this in this question is that if you go on to do 4.6, you actually need this value of t to do 4.6. And so they don't want you to go and do a whole bunch of wrong calculations with your wrong answer for 4.5, okay? So what you must do is when you get to 4.6, use this information to work out what's the value of t, because they've just told you here that 1/12t, okay? The ball made contact with the glass for 1/1,2 t, okay? And then the contact time of the steel ball is 0,289 seconds. So this means 0,289 is actually 1/1,2 t. So this is just algebra. You can actually work out t from this, okay? But we want to end up proving this. So now I'm going to rub out this other stuff over here, okay? I'm going to leave the answer to 4.4 because we're going to need it later. But I'm running out of space, so I want to rub out all of this stuff so I can come scribble over here as well, so that we've got some space to answer this question. Goodness me, this is taking long to rub out only parts of things. Okay, so we just need to have a little bit of focus while we answer this question. It's not hard, but you need to cut through all the words and make sure the words are making sense to you in terms of your diagram of what is going on, and also the gradients and the values on the graph. Okay, so it says to you now to what does it say to you? Show that the contact time of the steel ball with the glass pane is 0.289 seconds. So we can actually say, when is the ball contacting the glass pane? Okay, and when is it going to the ground? So we can actually use the equations of motion to solve this. Okay, so we need to find the contact time of the steel ball with the glass pane is 0.289 seconds. So this is the time it's in contact with the glass pane. So what was its initial velocity? If we read it off the graph, when it made contact with the glass pane at C, the initial velocity was minus 1,9, and my final velocity was minus 0,6. Okay, but we don't actually know here what this acceleration is, so this is a bit of a problem. We can't actually use this. So this is for CD. So this is where I say you have to bear with me, because we have to do some thinking here. We actually need to find DE, because DE, we have a known acceleration, because over here, what is the acceleration? We don't know. And so we can't actually do this using that equation of motion. But if we go have a look at for DE we know the same thing. At D, VI is minus 0,6, okay, and at E, VF is negative 4. And we know for this one, at this point it is being a projectile, because remember this is after it's hit the glass pane and it's parallel to the other parts of the graph. So this one's acceleration is negative 9.8, and then we can just use VF equals VI plus A delta T, okay. So negative 4 equals negative 0,6 minus 9.8 delta T. So we end up with algebra calculator. Delta T gives you 0,346 seconds. Okay, so this T DE over here is going to be 0,346 seconds. Okay, 346 seconds. But it says to you CD equals 1 over 1,2 times T, but we've just worked out that this is T, 0,346, and if you plug this into your calculator, you end up with this value 0,289, okay, seconds. So that is what the question asked you to prove. Show that the contact time of the steel ball with the glass pane is 0,289 seconds. And because in the CD section, the acceleration is not the acceleration due to gravity, you can't directly calculate it. You have to use this projectile part of the motion to figure out a time and then backtrack. Okay. So now the last other interesting part of the question. It says the acceleration. Okay. The acceleration during its contact with the glass, which is what? CD. Okay, remember we marked it on the graph. The acceleration during its contact with the glass compared to its acceleration on the ground. So now which part of the graph is on the ground? Remember right at the beginning we identified EF as being when it was on the ground. The acceleration during its contact with the glass compared to acceleration on the ground is in the ratio of 1 is to 4,3. Okay. Now it says calculate the ratio between the impulse on the glass and the impulse on the ground. So this is glass and this is ground. Okay, and first we've got the acceleration. Now they want the ratio between the impulse on the grass and the impulse on the ground. But now what do we know about the impulse on the glass? Remember, this is actually 4.4. So this value is going to end up into this. We're going to want to know 0,208 in a ratio to the impulse on the ground. So how do we calculate impulse on the ground? We actually have to have the this formula over here, the change in velocity. But the problem is we have an initial velocity here where it hits the ground, -4, but we do not know what the final velocity is. So what we have to do is we have to work out what is the acceleration on the ground, okay? But we've just worked out what this time was for the contact with the glass, okay? And it's also here, it's given to you, this time is 0,289. So we can go back, okay, and in this 4.5, remember I said to you we couldn't do this because we didn't know the acceleration when it was in contact with the ground. We can find, with the glass, sorry, we can find this acceleration here using the same formula, Vf equals Vi plus A delta t, because my final velocity is -1,9, okay? No, I'm lying to you. My final velocity, if I can read my handwriting, is -0,6. My initial velocity is -1,9, and then the time, remember they told you in the question, is 0,289 plus 0,289 A. So if you put everything in there, you're going to end up with a value for A for the acceleration on the glass, and it's a positive value. It's 4,498. Okay, so once we've got this acceleration value for the glass, remember we've also got this ratio that they told us. So if we find the ratio of the acceleration on the ground, we can find, the acceleration on the glass, which we've just done because it was that section CD, okay, we can then find the acceleration on the ground because of this ratio. So we're going to come back in here once I've rubbed everything out. And remember it said here right at the beginning of the question, the acceleration with the glass and the ground is 1 is to 4,3. So if 1 is to 4,3, 4,498 is going to be in the ratio. This works out to something like 19,342 meters per second, okay? So now we've got the acceleration on the ground, and you can see that ball, you can see this makes sense. The slope of this graph is much steeper than this slope, so it makes sense that it's this bigger number of 19. Okay, now it says to you calculate the ratio between the impulse on the grass and the impulse on the ground. So we want to be using this delta P formula. Okay, remember this delta P formula. We want to find the delta P for the ground. Okay, so if we find the delta P for the ground, we need to find the final velocity over here because we don't have it. Excuse me for my sneeze. Okay, so if the contact time on the ground is 0,669 t, we're still going to be using this Vf equals Vi plus A delta t. They've told you the contact time on the ground is 0,669. So it started here at -4 when it was hitting the ground first. Can you see here's where it hit the ground? Plus this 19,342 we've just calculated, times this time that they told us in the question, 0,669. Okay, and then you will end up with a final velocity of I'm not sure what, I haven't worked it out, but either way, once you found that final velocity, You're going to put it in here into this MVF minus MVI. Okay, and once you've done that, you get the two values, and then you're going to take this 0,208 and you're going to take this value and you're going to put it in there, and you're going to find a ratio. And I can't remember what the memo says the ratio is, but what you must do is find the ratio and divide by the smallest number so that you get 1 is to whatever it was. I can't remember. So just go ahead, and I've shown you all the logic. You can find this final answer by yourself. Now that you understand how to get there, work it out on your own. I wonder how many of you are still watching.